Okay, hello class. So today we're going to determine whether a relation is a function or not a function. In the previous video, we talked about a relation and how to determine the domain and range of a relation. So this time we're going to um, go a little bit further. We have, well, let's first define a relation. It is any set of ordered pairs. And contrast that with function. Function is a correspondence from the first set, which is the domain, and the second set, which is the range, such that each element in the domain corresponds to exactly one element in the range. So, to better understand that, let's go ahead and take a look at some examples. Let's say, for example, I have a set here, okay, set A, and I have a set B. Set A contains the elements 1, 2, 3, 4, and set B contains the elements 5, 7, and 8. Okay, so assuming that we have a correspondence from 1 to 5, so the relation is defined this way. And 2 corresponds to 5. Now 3 corresponds to 7 and 4 corresponds to 8. So that's how the relation goes. Okay, if we were to write that in a roster method, remember roster method, you have to put them inside a set of brace or open and close brace. Okay, so that means the ordered pair is gonna be, well, the ordered pairs are starting from the correspondence from 1 to 5, and then the other one is 2 to 5, the other one is 3 to 7, and the other is 4 to 8, so they're all in ordered pair form. Okay, now because the definition says it's a correspondence from the first set to the second set such that each element in the domain corresponds to exactly one. Okay, so we're going to ask ourselves how many elements does the first element in set A corresponds to? If it's more than one, then it's not a function. If it's all of them are just exactly one, then the relation is a function. Okay, so 1 corresponds to 5, therefore 1 corresponds, we can say that it corresponds to one element. Okay, so 1 corresponds to just one element on the second set. What about the second element, the 2? 2 corresponds to 5 also, so we're going to say it corresponds to 1. The 3 corresponds to 7, so it only corresponds to one element in the second set. And the 4 also corresponds to one element of the second set, which is 8. So all of them corresponds to just one element of the second set. Therefore, this is considered a function. It satisfies the definition of a function. Okay, now let's take a look at another set or another relation on the right side. So let's say we have a set A and set B. Okay. So set A has elements, let's say for example, 5, 7, and 8. And set B has elements 1, 2, 3, and 4. So let's say for example the relation goes this way. 5 corresponds to 1 and 5 corresponds to 2, 7 corresponds to 3, and 8 corresponds to 4. Okay. Now, if we were to write the ordered pairs or the set of ordered pairs in a roster or listing method, it's going to look like this. Okay, 5 corresponds to 1, so it's going to be 5 comma 1 inside of parentheses, and 5 comma 2, and 7 comma 3, and 8 comma 4. Okay, and then close brace to indicate that it's a set. All right, and then each we're going to analyze each of the elements in the set A to see if all of them correspond to just exactly one element in the second set. Okay, so let's do let's analyze 5. So 5 corresponds to what? To 1 and also 2. Therefore, the 5 corresponds to two elements. That fails then. That makes it not a function because there's one element in the first set that corresponds to more than one in the second set. So even though 7 only corresponds to 1 and 8 only corresponds to one element, that that's it's still considered not a function because of the 5 with two correspondence or two elements that it corresponds to. Therefore, the second relation is not a function. Okay, and if you have any questions, you can email me or send me a text. But let's go ahead and have some more examples. Okay, so here you're going to determine whether the relation is a function or not a function. And before I proceed to this one, let's also go back um, to the set in raster method. In the function side, notice that the elements or the first elements like 1, 2, 3, and 4 only shows up one time or show up one time. Okay, like 1 only shows up one time, 2 only shows up one time, 3 only shows up one time, and 4 only shows up one time. Whereas here we got the 5 that shows up twice. Okay, we got 5 here, 5 here. That tells us that 5 corresponds to two elements. Okay, therefore, when you're analyzing a set in this form, in a raster form, just look at their first element. If they shows up, if they show up twice, that means it's not a function. If there's any element that shows up more than once, then that's not a function. Okay, so here we're going to have some practice, determine whether the relation is a function or not a function. So number one, we have the set of ordered pairs 1, 2, and another ordered pair 3, 4, and another ordered pair 5, 5. Okay, is it a function or not a function? All right, ask yourself, is 1 showing up 1 or more than 1? Okay, it's only showing ones. 3 is only showing ones. 5 is only showing ones. Therefore, this is a function. Okay, number 2. We have a set of ordered pairs 3, 4, 3, 5, 4, 4, and 4, 5. Okay, is it a function or not a function? Let's go ahead and take a look at the first elements like 3. 3 shows up twice, therefore that tells us that this is not a function. And even the 4, it also shows up more than once. Therefore, this relation is not a function. Okay, let's have another example, number 3. So tell me if it's a function or not a function. We have the 4, 5, 6, 7, and the order pair 8, 8. Function or not a function? Again, let's take a look at the first elements. The 4 only shows up one time. 6 shows up just once. 8 shows up just once. Therefore, this is a function. Okay, fourth example. 1, 4, 1, 5, and 1, 6. Function or not a function? Let's analyze. One, we got one here, and one here. So that tells us that one corresponds to 4, 5, and 6. So it corresponds to 3, which is more than one. Therefore, it's not a function. So if you notice, it shows up 3 times in the relation in the first component. Therefore, this is not a function. Okay, let's take a look at another example, and this is going to be our last example. I know by this time you probably got it all nailed down, but yeah, let's have some more. Just this is the last one. 5, 1, 4, 1, 5, 1, and 6, 1. Okay, function or not a function? Okay, 4 shows up just once, 5 shows up just once, and 6 shows up just once. Therefore, it is a function. Okay, again, if you have any questions, please feel free to ask, email me, or text me.